So this is acid, bases and salt. This is very important chapter and it will be repeated in higher classes also. Okay, acid, bases and salts. So substances are classified or compounds are classified on the basis of their physical and chemical properties. Okay, so in terms of acid, bases and salts, the way their physical properties differ and chemical properties differ, they are classified into these three broad groups. Okay, so let's see what this chapter says. We use in our daily life a large number of substances such as lemon, peppermint, common salt, sugar, vinegar. Do they have the same taste? No, because different substances have different taste. Let us recall tastes of some edible substances listed in table 5.1. So this is a physical example activity. You can taste and mention what is the taste of some substances, that is edible substances. If you have not tasted any of these substances, taste it now. So it is saying that if something that you have not tasted, you can taste it, because these are edible, you can eat it. There is no harm in eating these substances. So you can taste and write their taste in the table. Some of the substances we know, and that can help us in understanding what this chapter is trying to say. You will find that some of these substances taste sour, some taste bitter, some taste sweet, and some taste salty. Yeah, right. Different substances have different taste, and these are the four common or major tastes. Okay, common tastes that we come across in day-to-day life also, like sour taste, bitter, sweet, and salty. So acids and bases: curd, lemon juice, orange juice, and vinegar taste sour. So these are the example of substances that taste sour. These substances taste sour because they contain acids. Now here it is clear why these substances taste sour. So these substances taste sour because of the presence of acids in them. There can be different types of acids, that is different thing, but acid is something which will make any substance taste sour. The chemical nature of such substances is acidic. The word acid comes from the Latin word acere, which means sour. So acid itself means sour. The acids in these substances are natural acids, and in these substances, lemon juice, curd, orange juice, okay, vinegar, so there the acid content, whatever acid is in them here, are natural acids, means the acids which occur naturally. What about baking soda? Does it also taste sour? If not, what is its taste? Since it does not taste sour, it means that it has no acids in it. When substances, edible substances, doesn't have sour taste, it means that there is no presence of acid in it, or acid is not present in those substances. It is bitter in taste. It is not sour and it is bitter in taste. So bitter in taste will indicate something else. It will indicate that acid is not present. That is one thing. So what else is present there? So bases are present there. Okay, acids are not present there, bases are present there, which makes those substances bitter. If you rub its solution between fingers, it feels soapy. Okay, so bases are soapy in touch. Okay. Generally, substances like these, which are bitter in taste and feel soapy on touching, are known as bases. The nature of such substances is said to be basic. The substances where bases contents are more are basic substances. Okay, the substances are said to be basic. If we cannot taste every substance, how do we find its nature. Also, it is a possibility that we cannot go and test each and every substances. Okay, some substances are edible, some substances are not edible or non-edible also. So how do we identify those substances are acidic in nature or basic in nature? So that is a good question, how to identify. So there has to be some mechanism to identify and test. Without testing is one thing. Without testing also there can be different method to identify the acidic or basic nature of any substances. A special type of substances are used to test whether a substance is acidic or basic. And to test acidic and basic nature of substance, the special types of substances are used. Okay, now we will come across those special types of substances which can be used to test acidic or basic nature of any substance. These substances are known as indicators. So at first place, these substances are called indicators, which are used to identify that a given substance is acidic or basic in nature. The indicators change their color when added to a solution containing an acidic or a basic substance. So what is the function of indicator? So when indicators are brought to acidic substances, its color will change. Okay. Likewise, its color will change when it can be brought to basic substances also. So it means that the indicators change their color when added to a solution containing an acidic or a basic substance. Turmeric, litmus, China rose petals, gulal, etc. are some of the naturally occurring indicators. So these are the examples of some of the naturally occurring indicators. Now this table is important because it says which type of acid is found in which type of product, okay, or which type of substance. So acetic acid is found in vinegar. Formic acid is in ant's sting. So we get burning sensation because of that acid. Okay, ant's sting. Citric acid. Okay, it is present in oranges and lemon. Lactic acid is present in curd. Okay. Oxalic acid is present in spinach. Ascorbic acid, amla, citrus fruits. It contains vitamin C. Okay, so amla, citrus fruits are rich in vitamin C. Tartaric acid, it is present in tamarind, grapes, unripe mangoes, etc. So unripe mangoes are also sour in taste. So it has this acid, tartaric acid. All the acids mentioned above occur in nature. Since these acids are present in these edible substances, so it occurs in nature. Directly it is present in nature. Name of base and where it is found. So calcium hydroxide is present in lime water. Ammonium hydroxide is present in window cleaner. Sodium hydroxide or potassium hydroxide is present in soap. The soap is also basic in nature because it is soapy in touch and it has bitter taste. It is non-edible, but we feel its taste is bitter. If we keep it a small bit of it on the tongue, it will be bitter in taste. So if substances which are not edible can be tested using litmus paper or naturally occurring indicators also. So that is the right way to test the acidic and basic nature of substances which are non-naturally occurring. So magnesium hydroxide is present in milk of magnesia. Now natural indicators around us. So we will discuss now some of the natural indicators which occurs around us. So one is the litmus, a natural dye. The most commonly used natural indicator is litmus. It is extracted from lichens. So litmus is naturally occurring indicator which are extracted from lichens. It has a mauve, purple color in distilled water. Its color is purple in distilled water. When added to an acidic solution, it turns red, and when added to a basic solution, it turns blue. So this litmus changes its color to red when it is added to acidic solution. When added to acidic solution, it turns red, and when added to basic solution, it turns to blue. It is available in the form of a solution or in a form of strips of paper. So it is available in a form of strips of paper. So it is very easy to use it. Just dip holding one corner of it in any solution, acidic or basic, you will get to know by seeing the change in color. Generally it is available as red and blue litmus paper. Generally it is available in red and blue because when you test for acidic, you will use blue litmus, and blue litmus will turn to red. Okay, and when you use red litmus to basic substances, it will change to blue. The red litmus will change to blue. The red will change to blue in basic solution, and blue will change to red in acidic solution. This is correct. Acidic solution, blue to red. Basic solution, red to blue. So this is the activity. Mix some water with lemon juice in a plastic cup, tumbler, test tube. Put a drop of the above solution on a strip of the red litmus paper with the help of a dropper. Is there any change in color? Repeat the same exercise with the blue litmus paper. So whatever I have said above is given as an experiment here. Note down if there is any change in color. Perform the same activity with the following substances: tap water, detergent solution, aerated drink soap solution, aerated drink soap solution, shampoo, common salt solution, sugar solution, vinegar, baking soda solution, milk of magnesia, washing soda solution, lime water. So they have named here, names are given of common substances which can be found around us easily from a shop or at our home also. If possible, make solution in distilled water. It is saying that dilute it. No need to take like full concentrated shampoo because it will be wasted after the experiment. So take some dilute, some portion of it in water. You will still get the result what you want. Record your observation as in table 5.2. So it is asking to check the acidic and basic nature of the substances or the change in the color of the litmus paper. The solution which do not change the color of either red or blue litmus are known as neutral solutions. So those substances are there which doesn't have any effect on litmus paper. Litmus paper color doesn't get changed. So those substances are neutral substances or neutral solutions. If you are making it dilute solution, it is solution. So neutral solution. These substances are neither acidic nor basic. Okay, now it is saying turmeric is another natural indicator. So turmeric, that is haldi, is another natural indicator. Take a tablespoon full of turmeric powder and a little water and make it a paste. Make turmeric paper by depositing turmeric paste on blotting paper. Filter paper and drying it. Okay, blotting paper or filter paper. So you apply this turmeric paste on blotting paper or filter paper and dry it. Cut thin strip of that paper. Okay, so it, because of the turmeric, it will look yellow. Yeah, you get a cut thin strip of yellow paper of 10. So yellow paper thin strip you can form or you can cut and keep. Put a drop of soap solution on the strip of turmeric paper. What do you observe? Now put some soap solution on that yellow turmeric sheet or strip of paper. Similarly, test the solutions listed in table 5.3 and note down your observation. You may try solutions of other substances also. Okay, you can make solutions of other substances also to test with turmeric indicator. Now you can prepare a greeting card for your mother on her birthday. Apply turmeric paste on a sheet of plain white paper and dry it. Draw a beautiful flower with soap solution with the help of cotton bud. You will get a beautiful greeting card. So there is a change in color and you will see a good greeting card. Turmeric is applied on it, and with the soap solution you are able to make some colorful drawing on it. It will be of one color only because solution will change it to one specific color. Collect some China rose, gulal, pastes, petals. Collect some China rose, that is gulal petals, and place them in beaker. Add some warm water. Keep the mixture for some time till water becomes colored. Use the color water as an indicator. Add 5 drops of the indicator to each of the solutions given in table 5.4. What is the effect of the indicator on acidic, basic and neutral solution? China rose indicator turns acidic solution to dark pink, magenta, and basic solution to green. Okay. So China rose is another indicator which turns dark pink when brought to acidic solution. Paheli brought the following Paheli riddle for you. Okay, where is that riddle? Okay, here it is. Coffee is brown and bitter in taste. Is it an acidic? Is it an acid or a base? Okay, don't give the answer without any test. You are in the dark with its taste. Okay, so you are in the dark. You have to taste it and find out whether it is acidic or basic. So something is bitter in taste means it is basic. Okay. So activity 5.4. The teacher is requested to get the dilute solution of the following chemicals from his/her school laboratory or from a nearby school: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, ammonium hydroxide, calcium hydroxide, lime water. Okay, calcium hydroxide is lime water. Are you familiar with the term acid rain? Have you ever heard about damaging effect of acid rain? As the name indicates, the rain containing excess of acids is called an acid rain. Where do these acids come from? The rain becomes acidic because carbon dioxide, sulfur dioxide and nitrogen dioxide, which are released into the air as pollutants, dissolve in raindrops to form carbonic acid, sulfuric acid and nitric acid respectively. So some substances are given here, names are given here. Okay, carbon dioxide, sulfur dioxide, nitrogen dioxide changes to carbonic acid, sulfuric acid and nitric acid respectively. It means carbon dioxide changes to carbonic acid, sulfur dioxide changes to sulfuric acid and nitrogen dioxide changes to nitric acid respectively. Acid rain can cause damage to buildings, historical monuments, plants and animals. So these are the damaging effect of acid rain. Caution: great care should be taken while handling laboratory acids and bases because these are corrosive in nature, irritating and harmful to skin. So these are corrosive to skin also. You will feel burning sensation when acid or bases directly fall. If it is concentrated, it will harm more, okay, on the skin. Demonstrate the effect of the 3 indicators on each of these solutions. Record your observation in table 5.5. Neutralization. We have learned that acids turns blue litmus red and bases turns red litmus blue. Let us see what happens when an acid is mixed with a base. We are going to use an indicator you have not used so far. It is called phenolphthalein. Okay, phenolphthalein. This indicator we will use now in the activity.